In this video, we're going to focus on learning objective A. We're going to define if an expression is a polynomial. If so, we'll state its degree, identify the leading coefficient, and the constants. So the definition of a polynomial is an expression that's in this format, where really what's going to change is the little exponent. And here they have n, n minus 1, n minus 2, where n is a positive integer, and it can include the number 0. So for example, if we had an equation such as here we have 2.38 is actually a polynomial because it does have an exponent here for n. The exponent is 0, because if I were to write 2.38 times x to the 0 power, remember anything to the 0 power is the number 1. So this is technically called a polynomial. It's a polynomial of the highest degree, or the highest exponent is a 0. So it's of degree 0. And what we do is we call this one a constant polynomial. Now if we bring it up 1 degree, so it's a polynomial of degree 1, I can tell it's of degree 1 because the highest exponent for my x's right here is x to the first power. It's just not listed. And what we call those is a linear polynomial. Now if we go to degree 2, that just means the highest exponent in our equation or expression will be a 2, which is right here, and we call that one a quadratic. When we go to degree 3, the highest exponent again right here is 3, and that one is called a cubic. A 4th degree polynomial, highest exponent here is a 4. This one is called a quartic, just like there's 4 quarters and a dollar. And the last one we're going to address here is a 5th degree polynomial. Here we have the highest degree is a 5, and this one is actually called quintic. Now all of these expressions do have a leading coefficient. The definition of the leading coefficient is the value in front of the term with the highest degree. So if we look at these examples, and I was asked what is the leading coefficient, let's start from this quintic one. The highest exponent is x to the 5th power. The leading coefficient on here is the number 1 over 30. For the 4th degree polynomial, the leading coefficient, there's a number 1 here, so it's plus 1. For the cubic, it is a 2 is the leading coefficient. For our quadratic, the y squared is the largest. There's actually a 1 in here, so the leading coefficient on this is a negative 1. For the linear, the leading coefficient is going to be a 4. And for the constant, the leading coefficient, I guess you would say, is 2.38, but technically what we would actually call the 2.38 versus a leading coefficient, better term for that is actually a constant. And let's talk about that. The constant is the number that's by itself. It's the one that will stay constant as the x value changes. So for each of these, let's identify the constant, and I'm going to circle that in blue. The constant for this first one really is the 2.38. That's the best answer for that one, versus again saying a leading coefficient. For the linear, the constant value is the positive pi. For the quadratic, there is no constant value here because there isn't just a number by itself. For the cubic, the constant is the number 9. For the quartic, the constant number is 0.7. And for the quintic, again, there is no constant number because every term in here has an x value. So all 4 of these terms will change as the x values change, and there is no constant. Now, standard format just means you're going to put the highest exponent first. And let's just go ahead and see if any of these are in standard format. So as they're written right now, I can tell that this quintic equation is in standard format already, so that's good. If we look at the quartic, this quartic one is not in standard format. To put it in standard format, we will put the positive t to the 4th first, Then the squared is next, so negative 81t squared, and then it's a positive 0.7. Our cubic is in standard format. Our quadratic is not in standard format, so let's adjust that one. The quadratic would be negative y squared and then plus y in standard format. And then the last two are in the right formats. Let's wrap up all that vocab with looking at this particular expression and identifying the key things. The degree of this expression is a fifth degree polynomial because it's the highest exponent. The leading coefficient is the number in front of that highest exponent term, and it's right here. It owns a sign in front of it. Be careful, it's negative 1 over 10. The constant for here, as t changes, every term in here is actually going to change. There is no constant term, so technically the constant is 0, because what I could have on here is plus 0. Standard format, this does need to be adjusted. T to the fifth is first, then t squared, and then 6t. So for the standard format, we would write it so it looks like this.